Okay, so a super dart of mass 30 grams traveling at 250 meters per second strikes a steel plate at an angle of 30 degrees with the plane of the plate, as shown in the figure. It bounces off the plate at the same angle and the same speed of 250 meters per second. What is the magnitude of the impulse that the plate gives to the bullet? Okay, so the question wants us to find the impulse. And we're given two velocities of equal magnitude. Now, since we're given degrees, we know that this is a two-dimensional problem in which that we're going to find the change of momentum along the x and change of momentum along the y. And since change of momentum is a vector quantity, we're going to find the resultant, meaning we're going to give x and y values. So we're going to consider the plate, our plane, which is going to be our x for this arrow. And given that the arrow is going this way, we have a positive x direction vector. And the same thing goes for this arrow. It's also going along the positive x direction. So thus a positive x vector. Now let's find the y component for this arrow. Since this arrow is going downwards towards the plane, we're going to set the y component negative as such. And since this arrow is going upwards, it's going to be considered a positive y component. So quickly, let's assign our x and y components. For this arrow, we're going to have v cosine theta. And then for a y, there's going to be negative v sine theta. X component for this arrow will also be v cosine theta. And the y component for this arrow will be v sine theta. And the reason why I put negative is because that this vector is in the negative y direction. So now that we've assigned our x and y components, let's solve for impulse. The formula for impulse is mass times v final minus v initial, or mass times the change of velocity. And now since this is a two-dimensional problem, we're going to find the x and y component of impulse. Let's start with the x component of impulse. We'll set that as Ix. Now the mass is 30 grams, and we're going to convert that to kilograms, which is 0.03 kilograms. Now we know that the velocities don't change before and after. And since there is no change in velocity, it's going to be 0. So the impulse of the x vector is going to be 0. Now let's look for the impulse of the y vector. In this case, it's going to be the mass times our v final sine theta minus our negative v initial. Now let's plug in our values. The mass again is the same, 0.03 kilograms. Final velocity was 250 meters per second, 30 degrees for the final. Let me fix this really quick. And since we're subtracting negatives here, I went ahead and changed it to a positive. I'm going to continue to solve. Now to finish this problem, using Pythagoras' theorem, to find the resultant impulse, I just have to square root the impulse of x squared plus the impulse of y squared, which this is just going to be 0. This square is going to get rid of this square. This square root is going to get rid of this square. So our resultant impulse is going to stay at 7.5 newtons.